Hello again, and in this session we will look at few other technologies for 3D printing. We have finished vat photopolymerization in the previous session. So, now we will try and cover material extrusion, material jetting and binder jetting like you see on the screen here. So, before getting started, maybe another analogy for you to understand 3D printing process better, and this is my personal favorite of how 3D printing is done, and I say that it is often like the reverse of cutting a loaf of bread into slices. In 3D printing, what we do is we put one slice of bread and on that another slice of bread, another slice of bread, and then we make the complete loaf of bread. And we consider each slice as a 2D slice, very thin layer thickness basically. It could be as low as 20 micron thickness each slice, and it could be as large as let us say 100 microns or 150 microns, even 200, 300 microns. So, each layer is in terms of microns for us, and hence we consider it as 2D, and when you go on putting these layers one upon another, then we get the entire loaf of bread. These layers have to stick to each other very well, so that the solid model has some good strength and mechanical properties, right. In the last session we saw how this is achieved from liquid resin. Now we will look at another technology which is a material extrusion, right. So, material extrusion is the second of the technologies that we have listed, and these categories are according to ASTM, like you know, and it is also called as FFF, fused filament fabrication. You will see some blue boxes in some of the on some of the acronyms, right. The blues represent technologies in which we as Wipro 3D have expertise in or have in-house capacity with. So, FFF is a technology that we do have in-house and experience working with. Let us dive into it, right. So, here is the schematic diagram again, and let me zoom into this to explain how this particular process works. As in any process, be it SLA, FFF, DLP, whatever, right, we always print on a substrate, and this is number one part that you see here, and that is a plate. It could be plate, sheet, bed, different names. In case of FFF, it is a very thin sheet that we use. Now, on this plate, we will deposit the material. The raw material itself is in form of a polymer filament, and that you see in this picture as number 2. So, this filament is wound on a spool, and from the spool it is made to come on a roller, and it is made to pass through 2 rollers, which over here is named as part number 3. It comes through or between those 2 rollers and then hits the hot region of the nozzle. So, the entire grey thing that you are seeing along with a little bit of green is all called an extruder or a nozzle. So, let me try and point out to it. Okay. So, what you see over here, this entire thing is the nozzle, and the filament is coming from the spool into this, it is past the nozzle, the rollers, and what you see over here is the heating element. So, this is the heating element. When the filament passes through this heated element, it will melt, and the melted material is then deposited in 2D layers like you are seeing here. All right. In FFF technology also, you have to remember and notice that there are support structures required. There are support structures required even for material extrusion or FFF technology. There is one variation that is possible in FFF technology, which is if you are considering to print a part, you can try and make the inside of the part hollow with certain infill. That is also possible. For example, if we want to, let me choose another color. So, let us say that this is the region that I want to melt. This is the top view. When I see from the top, this is the region that I want to melt. Let us say if I see it from the front, it is a layer like this, okay, and in isometric this is how it will look. So, if I look at this from the top, what I see is a rectangle. Now, this rectangle, I have this is the region where I want to deposit. Now, I have the option here to deposit material. Let me try and use another color. Give me a second, I do not think that is a good color. So, yeah. So, I have the option to go from one end to another end very close to each other and deposit the material, but and then the entire thing will be completely solid because the lines are very close to each other. But if I want to save material, I want the process to be faster, then what I can do is I can deposit the material with some gap in between, right, and also like this. So, this region is called as infill. This region is called as infill. In case of material extrusion, we have this option of keeping the part hollow on the inside. Infill percentage can be 30%, 10%, 80%, depends on what we want to achieve. So, the infill can be hollow. However, the boundary of the part has to be completely solid, right. There is no compromise on the boundary being completely solid, only the inside of it can be hollow, and this is called as infill. So, FFF technology builds with certain layer thicknesses which are usually a bit more than SLA technology, hence it is a slightly faster process than SLA, but if you look at let us say MJF or some other technology, the speed could be lower. But this is a technology which is extremely easy to handle. It is also a very cheap and simple process. So, it is possible to procure these printers very easily from the market at quite a less cost, and it is very simple and easy to handle. So, with very few directions you can start to use this particular printer. Another advantage is that a lot of different materials can be processed using this particular technology. Polymer, of course, like thermoplastics can be very easily processed with this particular technology, and you have different kinds like very high performance polymer machines like PEEK, PEC, ABS, which is a very hard and strong material. All of these materials can be processed using FFF technology. It is also possible to process a flexible material called as TPU using this particular technology. So, the range of materials that are available that can be processed is already high. And these days, if you are able to make a metal filament along with some, let us say, binders, then even that metal can be processed using this particular technology. However, we should remember that after printing process, then we will have to do desintering, debinding and sintering processes to get the final part. So, there will be some extra steps involved. Composites can be printed very easily using this. So, imagine while making this particular filament over here, let us say we will add some different kinds of fibers into it. Like for example, I know like students are trying to mix cotton fiber, banana fiber, sugarcane fiber, all of this can be mixed into the polymer and the filament can be made, and when the printing process happens you would have printed with a composite. But carbon fiber, glass fiber, these are all also engineering composites that are quite well processed using this particular technology. Now, when we are talking about the different materials, then I should also mention that in the SLA technology which we discussed previously, it is also possible to print metal and ceramic. And how? It is by having a lot of metal powder suspended in this resin, right. And then again, like I told you, for FFF technology, we have to get rid of that polymer or resin by using debinding and sintering processes. So, slightly different way of achieving the final part, but it is a possibility. So, FFF technology is one of the most popular technologies. You will usually see a lot of people, hobbyists who have this even at their homes. There are certain limitations. Support structure is always a disadvantage in 3D printing, and in this process also. Low accuracy, I am saying, as compared to the SLA process. Relatively low speed, I am saying, compared to, let us say, a DED process for example. So, these are only relative to each other. And I told you the reason this process is not as accurate as SLA process is because the layer thicknesses are higher than what we use there. Yeah. So, I hope the working of FFF technology or material technology is clear from this particular slide. Now, we will move on to discuss the different materials, and materials I already started to brief you. What is listed here are some of the most used materials, but like I was saying, it is possible to 3D print metal, ceramic with composites also with this particular technology. Slight extra processes will be involved. Stratasys, which is mentioned over here, actually had a patent on this technology till about, I think, about 10 years back, 10-12 years, and they call this technology as FDM, fused deposition modeling. So, it was patented by them and it is a trademark name for them. Many of you may know this particular technology as FDM, but probably the correct term to use for this is FFF or material extrusion. Now, the patents have expired and a lot of companies are making machines based on this technology, and Wipro also does the same. The variety of materials that are processed on this material also make it suitable for different applications, right. Robotic grippers are one such applications, and we can use a lot of pneumatic grippers and things like that made from material extrusion. in the robotics industry. One more very interesting thing I want to mention is the tooling. So, ABS and all that is a very hard material, hence what can happen is that we can print tools, jigs, fixtures using this particular technology. In fact, Volkswagen is one company which uses this technology very extensively and has saved a lot of money on their assembly shop line. Let us say for example, how Volkswagen may use it. I am not saying that this is a real example, but just any automobile company. Let us say there is a place where the screwdriver needs to be slightly longer for you to go and tighten something, or a wrench. In that case, what the company can do is they can 3D print an extension and they can use it. So, that is a very simple example of how you can make some custom tooling. Whereas jigs, fixtures, inspection fixtures. So, jigs, fixtures not only for machining, but even inspection, quick go, no go gauges, these can be made using FFF technology. So, that is one example of how FFF technology is used not only as an end part. So, this gripper is an end use part, but we are using additive technology to support production in the second example that I gave you, right. Here is a lifting tool and this is made from Ultem, that is another very strong composite, and this is used in marine application, wherein they have done all the testing for the part and they have qualified this part for the for an application where it is lifting quite heavy loads. So, what I want to say with this particular example is that additive is not for only prototyping, right. It is used for engineering applications and as end use parts. They are able to perform very well with good strength and mechanical properties. So, this lifting tool that I am mentioning is one such example. However, it is also being used in fashion industry, in other consumer businesses also, like maybe like making a joystick or something like that. So, one interesting thing I want to share here is Black Panther's mother in that Wakanda, right. She has this really nice headgear that she wears in white color. I forget the name of her, but yeah, the headgear that she wears, this is 3D printed. We are also seeing a lot of 3D printed fashion wear in Met Gala and different places like this. So, it is picking up in the fashion industry as well. One more is probably like prosthetics, right, or robotics also for that matter, where people may need like if you need like a special feature in a prosthetic hand, wherein maybe a Paralympic participant wants to grip a basketball, right, then it is possible to make it for him in a customized way, correct, because you are 3D printing, you are designing for this one person, it can be different for each person. So, let us say we have a team of 5 people and all the 5 people can will have different sizes of the hand, and all the 5 parts that you make can be customized to them. So, it can be customized for the need, for the person, these kind of things are also possible. So, this is in general possible with any additive manufacturing technology, but I am right now discussing how in FFF these are used. So, I mean, I think imagination is the limit. Basically, if you think of anything, you can do it. Let us say in the house you are a hobbyist and then the washing machine knob is broken or something like that. You can 3D print it if you are able to design it. So, the applications of FFF technology is really very, very high. The next technology that we will discuss is material jetting, right, and when we come to material jetting, it is very similar, I would say, to our color printing, and let me explain how that works using this diagram now. So, we have a plate again to start with, that is a given for every single time, and then we will have the raw material in form of liquid again here. So, it is probably a polymer resin, and in this case you can have two different materials. So, here you have an option where you can have one different support material and one actual part material. But this reminds me to also tell you that even in FFF technology that we just finished discussing, where you saw that the material was coming out of one nozzle, but in the machine you can put 2, 3, 4, 6, how many ever nozzles you want, and simultaneously you can print with different materials. So, maybe you are all printing with ABS only, but you can have a green color ABS, a orange color ABS material, and you can print with them, right. So, it is possible there, it is possible here also. Instead of having two containers, you could have more than two containers over here, and hence the colors or the mixing that you can get becomes even more varied. So, this liquid metal over here, I am sorry, liquid polymer over here will come through this print head. So, we call this the print head, just like how we have in our paper printing machine, and the material is then jetted out, it is sprayed in a way only where it is required. So, you will have very fine nozzles and material will be jetted out only where it is required. So, here you could have the support material, in this technology also supports are required, and the support material can be different and the part material can be different. Now, once the spraying is over, there is another step which needs to be done, and that would be the curing. So, once the spraying is over, in the same print head it is possible to have a UV light source, right, and this light source will help us to basically cure the resin which has been sprayed. So, this orange color blob that I wrote, consider that as a UV light source or some light source which will cure the polymer once it is sprayed, hence the shape stays, right, because it has gotten cured. So, this is MJ technology, material jetting. It is also sometimes called as MJT. So, material jetting technology. So, just add a T for technology there. So, that is another acronym and its expansion for you. What are the advantages? Even here you get extremely accurate and smooth finish parts, but owing to these different containers that we have, right, it is possible to have multi material and multi color prints. However, the limitations are that the machine, the printer itself could be quite expensive. You can't make very large parts like in FFF probably, and the only those which are curable by that particular light wavelength and all that, right, you are limited to those materials. Multicolor however is definitely possible. The applications, you can make very good prototypes using this particular technology, and colorful prototypes with texture, finish, however you want. Stratasys also makes this machine, they call it polyjet technology, exactly the same working principle, but a different name. So, you could have different names for the same technology, and you can have like wood finish, leather finish on the part, using different materials. So, extremely good prototypes you can do. Right now not many people use this as end use parts, but great fit for colorful prototypes. Now, quickly let me move on to the binder jetting process, and this process is a little bit more complicated to understand. So, I will get started with it right away and hope that I will be able to convey how the process works to you very well. Now, in this particular process, we work with powder as the raw material. Now, the powder could be a polymer, it could be sand. So, yes, sand can be 3D printed as well, could be ceramic, could be metal. So, material can be anything, but it should be in the powder form. Now, in these bins, bin number 1 over here as well as this bin, the powder will be loaded, and then we will have this particular roller or a recoater as we call it. This will take the powder from here, from the right, and completely coat it on this middle region over here. This middle region is where the actual printing happens. Trying to change the color of the pen. So, this middle region is where the actual printing happens. So, the roller, while moving from right to left and moving from left to right, it will coat a layer of powder in this green region. Once we have a layer of powder, then what you see in this container is the binder. It is basically a polymer which will harden very soon. This binder is then sprayed only where we want the solid geometry to form. So, only in these blue areas the binder will be sprayed. Now, once the binder is sprayed, again a source of light will come and it will cure the binder. So, what will happen when the curing is done is that these particles of powder, the particles of powder will be held together, but they will not melt or they will not solidify to form a solid. Okay. So, there is no solidification of the material at this particular stage. Whatever powder is there, and then we will have the binder, right. So, let us say the binder is in, no, the color has not changed, red. So, let us say the binder is in red color and there is binder in between all this. So, this binder will only harden and it will bind the particles together. Because it is not becoming a solid part over here, or there is no heat input, this technology, when you are printing with, no supports are required. So, supports are not required in this process of 3D printing. Now, after the part printing is over, what we will do is, we will raise this platform up. I am sorry, we will raise this platform up, and then whatever you see in light grey color here, all this will be in powder form only. So, all the powder is removed. This is called as de-powdering step. This is called as the de-powdering step. So, the first step over here is 3D printing it. The second step over here is the de-powdering. All right. Once the de-powdering is over, then we will do something called as de-binding. So, whatever is the binder that has been sprayed, this needs to be removed. So, de-binding step, right. Now, every company which makes a machine will also give its proprietary binder. So, in the de-binding step, what will happen is, all of these red binder that was there, it will evaporate, right, and from green part, this particular part is going to become what is called as a brown part. So, what you get from the 3D printed machine is a green part. Now, after the binder is removed, this will become a brown part. It has little better strength, but still not completely solid. So, now after the debinding is over, that is the binder has been removed, then what we do is the sintering cycle or the sintering process. Okay. Very similar to powder metallurgy. What we will do is then we will put this particular part inside a furnace and heat it so that it will melt and it will solidify, and in this process the powders will melt and then it will become a solid part in the sintering process. In the sintering process, let us say this, it is the same part over here that is getting sintered, then overhangs may require supports. In such a case, supports may be required, right. So, this is the binder jetting process. In the 3D printing process itself, you are only spraying the powder binder. So, there is no heat, there is not, the powder is not become solidified. So, you do not require supports, but during the sintering cycle you may require, may or may not require. Hence, you can make extremely complex parts, complex geometries like impellers and all of that using this particular technology. The process is quite fast because you are only spraying, and things can happen in parallel. So, let us say in the furnace some 10 parts are getting sintered, in the debinding station another 10 parts are getting debinded, but in the printer another 10 parts are getting printed. So, in the same timeline you are actually processing 30 parts instead of just the 10 which are getting 3D printed, right. So, parallel processing is possible. However, today the equipment cost is quite high. We are not able to make extremely big parts, because in this particular process we see that the shrinkage can be as high as 20 to 30%. So, we have to make the part larger, print it, sinter it and then bring it to size. So, the size of the component is right now a limitation. Limited material range in the sense not the sand, those kind of things, whereas like in metal only, then the process is right now proven only for, let us say, steel and titanium or maybe few other things. It is not proven for all the materials right now. So, that is why this particular point. You need a lot of ancillary equipment. Other than buying the 3D printer, you have to buy the furnace, the debinding station and all of that. So, those are some of the disadvantages. Like I said, polymer and that it is colored after the 3D printing process, it is not during the print, but yes, polymer, sand and some different alloys can be 3D printed. And what you see over here is actually a sand mold. So, sand mold, sand core, these can be 3D printed with binder jetting, and this is a very unique thing to binder jetting. Right. So, with this I finish 4 technologies out of 7 of the AM technology landscape, and in the next session I would provide a small summary of these technologies, these 4 technologies, as well as I will introduce you to the assignment that we will be giving at the end of this particular week. So, thank you and look forward to seeing you in the next session.